at any point and check on things as you need, or if anybody misses it, they can catch up. And those are all available in Moodle in the module, and it takes about 24 hours or so for it to arrive there. So just if you immediately want to check something, you might have to wait a bit or like. But thank you to everybody who's done their get to know your barrier product assignment. And I again say that those that I've marked, which is most of them, done a really wonderful job in finding the information, getting it there, looking at other products to get that difference, any differences, advantages, disadvantages. And that's something that certainly it's good to know those things, that there are slight tweaks on these different systems, but importantly understanding where you find out what its status is it approved, is it accepted for use, or these sorts of things. And I suppose a caution on that is to always go to the website and look at the most recent information, because it does change from time to time and you may not hear about that. So especially in Victoria, where it's a downloaded PDF document, what some people do is they have a copy of that and they just look at that copy, but the one on the website might have changed, and there may be reasons why a product's been removed or its status has been altered. So always check that out. So this session, we're going to get Jamie to run through quite a few sort of real world examples of things that are not great out there, or things that could be done better, or the like. And they're really there not just for your learning, so you can see some of these challenges. Jamie might talk a bit about what could have been done better, or some of them, it's a really hard situation, so you're going to have to make some compromises here or there. But Jamie will talk you through how you can think about those things from a risk perspective and a context perspective, and try to get the best outcome you can. And certainly, as I've mentioned a couple of times here, the course you're just about to finish at the end of this module, and once you finish your test and your assignment and everything, is equivalent to the fundamentals training course, which is a one-day in-person course. There is a follow-on course, a 2-day applications course, which goes into a lot of the design. You get out there, you do design, you're faced with these real-world constraints, you calculate your lengths and needs on things, you choose your barrier systems, then you get questioned on why you chose these things and did you account for these other things. And that's a really clear and vivid example of some of the nuances, the judgment, the compromises that you need to make, the real world situations where you can't fit everything you need. And so I encourage you to have a think about that when we're able to run one in person again. So we had a few people put forward a couple of topics for a little bit more discussion about. So we'll do that after Jamie's gone through his slides. So we're going to have a brief discussion about high profile barrier curbs, or curb containment barrier systems, and a little bit of a chat about pedestrian and cyclist fencing, and maybe even a little bit about how you do that on structures. So if there are other topics that anybody wanted covered, pop those into the chat or the Q&A, and I'll make sure we try to at least touch on those. If, as I keep mentioning, if you have a site or a design or anything that you'd like looked at and discussed live, please either email that to me or pop a link in the chat or the Q&A, and we can dive into the street view or the like. So we're in your hands after about an hour's time, I would say, but we'll maybe a little bit more than that. So yeah, keep the questions coming in. Jamie will probably throw a couple of your pictures to them to see if they can find some issues and give away a few last prizes. But otherwise, I'll hand it over to you.
Thank you, Ken. Just trying to share my screen.
Yep, looking good.
Now we're looking there.
Yep, see that? All looking good.
Right, good afternoon, everyone. Today I'd like to talk you through and share with you some of the common challenges associated with barrier design and installation, some of the things that I and my colleagues have seen out on site, some of those common mistakes that you might encounter as a designer or installer or a maintainer of these type of assets. So there are lots of different fingers in the pie when it comes to barrier installations, suppliers of products, and the number of those products really has increased. They've increased in terms of their level of complexity, and that has led to a number of the issues that we see with their installation. The suppliers' guidance around their products, it's come a long way, but certainly in the past, there were some holes, and that contributed to some of the issues that we saw with installations. Designers often play a part in it if they have a lack of understanding of the products that they're designing with. Installers who are charged with installing a barrier as per a design might take it upon themselves to do something a little different. They might not understand the products themselves. Components can easily be installed in ways other than they're intended, which can mean that the products simply won't perform. And there's been a real, a real lack of maintenance on some occasions, which has also meant that some less than desirable installations have slipped through the cracks. So lots of different things that can go wrong. Often the responsibility doesn't sit with with one. It's a bit of a shared responsibility. And here's a picture of a number of the products that have presented issues in the past. These are all now legacy products. They're not MASH crash tested products, but there is a heap of each of these out on their network, and we'll continue to maintain and repair these to the end of their useful lives. There's a whole new suite of products, as we've talked about, some of which are even more complex. So there's a new suite of products that the industry needs to become familiar with in terms of their design parameters, how to install them, what to look for if you're inspecting these installations, and so on. So there's a list of a lot of the common design issues that you might encounter. I won't read through those, but in a nutshell, a lot of these come down to designers not being familiar with the products that they can and should use. So perhaps not being across the approved products list and not knowing the ins and outs of those systems. So perhaps which one might be the most appropriate for a particular situation, and nominating things that simply can't be installed as per the intention of their design due to some constraint on site, perhaps. I'll show you some photos of each of those. Here we have a structure and an inappropriate transition between the road safety barrier and the on-structure barrier. There's an opportunity there for an errant vehicle to snag at this point here. This certainly isn't a standard or in accordance with a standard arrangement. Each state has these, and certainly the preference would be that this bridge barrier was integrated with that concrete end post there, and there was no opportunity for a vehicle to snag at any point on the barrier. At these type of locations, it's critical that there is an appropriate transition in terms of flexibility of barrier between the different systems that are used. This is a two-way roadway. You can see a gabion wall on the right-hand side that presents a hazard to errant motorists. A barrier has been placed in front of the hazard, and that hazard could have been a row of trees or anything. The decision has been made to install a trailing terminal. Now, that is probably a result of the hazard being located outside the old clear zone, and it's been deemed appropriate to shield it for one direction of travel only. We know that vehicles can and do travel well beyond those clear widths. And if one did cross over the road and strike this terminal end on, there's potential for a serious crash outcome. So the preference would be certainly to install a grate, an energy absorbing terminal on that end of the barrier. And even better would be to provide an appropriate length of need of barrier before the start of that gabion wall or any other hazard. Here we have a large tree very close to the back of the barrier. The upper part of the tree even extends in front of the barrier. This is certainly a design non-conformance. We haven't got the required width for deflection between that barrier and the tree. It doesn't appear that an effort has been made to stiffen up the barrier. So that is something that could have been done. Halve the post spacing to reduce the barrier deflection and reduce the likelihood that an errant vehicle would strike the barrier and then the tree. We don't have any allowance for vehicle roll. We haven't got we're not providing a working width. But that said, you might consider that a bit of a nonsense to try and provide that for a barrier of this type, because it's only a test level 3 or even test level 2 barrier, and you wouldn't expect it to contain a high vehicle in any case. So it is a case of doing the best that you can in a lot of these cases. The likelihood of removing that tree is slim, so you want to provide a barrier that will deflect by the least. It's a trade-off between how close the barrier is to the edge of the road versus the tree. A barrier of this type is probably appropriate, but you should be stiffening up the system and documenting any non-conformance associated with it, and demonstrating that you've thought about the issues and achieved the best solution in your belief. Evan spoke last week about short radius curve treatments, and this is one of those. The intention of these treatments is to contain a vehicle that strikes the barrier on the radius here. And you can see some frangible timber posts here. If that is struck in this area, the barrier will deflect inwards. And the requirement is to have a flat, hazard-free area in behind the barrier here. You can see that we haven't got that on this occasion, so any vehicle that impacts the barrier is then going to strike this cut face and probably come to an abrupt stop. So that's not a great use of that treatment. These treatments are allowed for in a number of jurisdictions. They are not ideal because of the high impact angles that we can have with the barrier. But in some cases, we don't have much of an option, and particularly where we've got a side road near to a bridge or something like that. I think the Vic Road standard drawings are titled something like that, treatments for approaches to bridges with side roads. And in those cases, you simply can't achieve an appropriate length of barrier to shield the drop off at the bridge. You're constrained by the side road, and wrapping around the barrier into the side road is perhaps the best that you can do. So this is that's probably the best use of a treatment like this. Here we have a barrier installed as per the old philosophy of locating barriers as far as possible from the travelled way, so as to minimise the chance of nuisance impacts and provide space for motorists to recover their vehicles before they strike the barrier. It also meant we could get away with some shorter lengths of barrier because the barrier was close to the hazard. But that really was the old way of thinking. The preference now would be to locate the barrier nearer to the roadway at that desirable offset of 3 to 4 metres to provide enough space for a vehicle to pull over at the side of the road, eliminate the possibility of rollover. We've also got a table drain in front here. The interaction or the behaviour of the vehicle as it crosses through that ditch and then strikes the barrier is a bit of an unknown. So this is a situation that we now like to avoid. Perhaps we can give a prize for anyone that can name this type of barrier. It's not one that has ever been on an Australian accepted products list, but unfortunately has been installed. Someone was gullible enough to succumb to the approaches of someone trying to sell them this product, and it did appear on the Victorian road network. As I say, it's never been an accepted product, and it was promptly taken out of the ground and replaced with an accepted product once this was discovered. I don't expect that anyone would know this one, Ken, but
big prize for that one. If anybody can tell us that one. No, I think keep you tell us, Jamie.
I'll give it away. It's the Minnesota bullnose, this one. So if anyone comes to you trying to sell this product, the answer is no. Another design.
Keep going. Yep. Sorry.
Another design non-conformance here due to a lack of space for deflection. The barrier has been stiffened up with some reduced post spacing, so that's a plus. The choice of system, however, is, I would say, not ideal. It's a wire rope, which is can be expected to deflect by more than any other system. A better choice would have been a guard fence product with reduced post spacings if that was deemed necessary. In a low speed environment such as this, and I'm guessing it might be 60 or 70 k's per hour in that order, we're not going to see those full crash tested deflections, but it certainly would be likely that the barrier would deflect by enough to strike that pole. I wonder what could be done better in this situation. It's a 100 kilometre per hour road in New South Wales that a colleague and I inspected. Any thoughts on what could be done better here in terms of providing a safer outcome for motorists?
Pop your thoughts into the chat. Any ideas? Or the Q&A, as we've talked about. Okay, Doug wants to extend the length of it towards where the camera is taken. Naomi's on board with that too, to try and cover more of that area. Alex likes that as well. He wants to flare it a bit as well. So that's good stuff.
Yep, I'm liking that. Yeah, the obvious thing would be to extend that barrier to shield more of the trees. There are obviously trees within the run-out area there, and trees that are exposed to errant vehicles that could pass in front of the barrier and enter that area.
Sorry, Callum's also with a very keen eye there, seems to be looking at the barrier on the other side of the road and saying maybe we could extend that to protect the embankment. So there's a little bit extra as well.
Yeah, no, that's a good suggestion. And I think there's a similar situation happening on the other side of the road, and it's often the case that we find barriers starting at the transition between cut and fill, or fill to cut. And those are locations where we often want to provide access to the roadside. And my impression on site was that was the intention of stopping this barrier where it did stop. To continue the barrier further on either side of the road here would result in the barrier extending in front of a cut batter. There may not have been sufficient width to do that in terms of catering for deflection. Another solution might be to remove trees, but that's not ideal or even achievable a lot of the time. Flaring, as someone suggested, would have been a good outcome.
Yeah, we've got some. Well, there's a bit more that's come in there. Questioning the need for curb underarm protection, so motorcycle underarm protection. Catherine's made a comment about the wire rope safety barrier in the middle, finish off the wire rope safety barrier in the median. I'm not sure what that's actually referring to. Might need a bit more detail on that, Catherine. Some good comments there. Any comment on the curb, Jamie?
It's a fairly sort of shallow channel. It's popular in New South Wales. It's got fairly gentle grades. It is desirable to not locate a barrier beyond any sort of feature like that might affect a vehicle's trajectory. But this being sort of as shallow as it is, or as gentle as it is, I wouldn't have a big concern. It's certainly not as severe as a semi-mountable curb or something like that. It would be necessary to have something in front of that cup adder for drainage. Further along the road, perhaps not so much.
Okay. That's good. Thank you, everybody.
This is obviously a median barrier in a very narrow flush median. And this is a treatment that has been or has become popular in Victoria in recent years. And there's been a real pressure to minimise the footprint where we've provided these treatments. And this median is only 1.4 metres wide. There are a number of cases where that has been provided in Victoria and some issues presented immediately. You can see here that this barrier here is a back-to-back guard fence. The only, I wanted to say, accepted product that can be used to terminate these barriers, well, it's not a MASH accepted product, but as of today, it's the only available median terminal product for guard fence is the extension median terminal, and it's particularly wide. It's about, I think it's 700 mil wide or thereabouts, which in a 1.4 metre wide median leaves very little margin for error on either side.
So, Jamie, well, there you can see part of it flattened. Just a question on that. This one, an X350 is not a MASH tested product. Is that right? So this is not a MASH tested product.
That's correct. So it's an NCHRP TL3 tested product. So until recently, it has been an accepted product. At the moment, there are no new MASH tested products that can serve this purpose. So for the time being, it's not an accepted product because it's not MASH crash tested, but it is the only available option. So it's likely that it will continue to be accepted for use until there are some alternatives.
Thank you.
So very shortly after this one was installed, it was taken out by the Coles truck that you can see there. Now, it was the first median barrier along this section of road that you would have encountered. So it really did jump out of the blue at approaching drivers. So there's been a lot of lessons learned around delineating these type of treatments and around the median widths that have been adopted at these locations. There's another location where we had a wire rope barrier in a median. At this location, the works hadn't even been completed. It was still under roadworks traffic management and reduced speed limits, but it was taken out, presumably again by a truck. An extensive length was damaged in this case, and it really does seem to be trucks that are striking these terminals a lot of the time. We've recently done a piece of work on the Princess Highway project in Eastern Victoria, which is this location. And there have been a number of high profile strikes with median terminals, and each of those has involved a truck. And the main reasons for trucks being overrepresented in these crash types is their increased width for a start, and their increased tracking width. They do generate more sway than a smaller vehicle. There were some pavement issues and various other things, sort of site-specific things that contributed to risk, but trucks really are overrepresented in these type of strikes. There have been no strikes along this road that have resulted in injury to, or certainly not serious injury to the vehicle occupants of cars or trucks. But when these type of strikes do happen, there's potential for other things. Trucks have burst into flames. They've ended up blocking carriageways. So there are flow-on effects that we want to avoid. So even though they're crash-tested products, we don't want vehicles to be striking them, especially in these type of situations. So delineation of these treatments really is key, and a whole bunch of different arrangements have been tried about the place. We've got some clem fix with paddle boards on the left, some narrow keep left markers. On the right, we've got this yellow cone and keep left arrangement that's popular in New South Wales. So both of these provide a good level of delineation. Tactile edge line is great, that helps. Raised pavement markers and so on. Some guidance has been developed in Victoria in response to the crashes that have happened around how to delineate these. So going forward, there should be a more consistent approach if these guidelines are followed. And the guidelines also do recommend a localised widening of the median at terminal locations. So the 1.4 metre median is still accepted, but where we do reduce to that width, we ought to be providing a wider, a greater median width at the terminal locations of something like 2.2 metres minimum. And the old 2.2 metre median width was based around providing a metre clearance on either side of a wire rope. The 1.4 metre bare minimum that we sometimes adopt, the intention of that was to provide a 0.6 metre clearance on either side of a wire rope barrier, and the 0.6 metre clearance being the absolute minimum as per Austroad's guides. The change to guard fence, back-to-back guard fence, further reduces that and increases the risk of strike. So be mindful of your barrier types in this situation. There are certainly some pros and cons for guard fence versus wire rope. Wire rope will deflect more and into opposing traffic lanes, so that's a consideration that needs to be made. That said, the likelihood of a barrier deflecting into that lane and a vehicle coming the other way at exactly the wrong time, I think, is very low. Obviously, it depends on traffic volumes and the amount by which we expect that barrier to deflect. And in medians, we often don't see great deflections because the impact angles are relatively low. They're not anything near that 25-degree angle that these products have been tested to.
Jamie, a couple of things. Yeah, so first of all, medium widths, where would you find that information?
In the Austroads guide has some a small amount of fairly vague guidance on median widths, and that relates back to sort of minimum offsets to barriers. In Victoria, there is a road design note around providing central barriers in narrow medians, and it provides guidance around median widths, delineation treatments at the start of these barriers. So that's a great resource. You can find that at the VicRoads website. And I'm not sure if we did include that as a PDF in your on your memory sticks?
I'm pretty sure we have. I'll check that after this. Another question's coming around concrete barriers in medians as well.
Yeah, concrete barriers are a great choice in high speed, high volume situations. So it might be an urban freeway where, for one, we're really quite constrained for space. So it suits to use concrete to minimise our roadway width. But we've got lots of trucks, roads performing a very important traffic function. We can't afford for heavy vehicles to penetrate median barriers and into the opposing carriageway. So those type of roads are where we typically use concrete. Some rural roads, we might use a concrete barrier where we have again, we're limited for space and we're mindful of deflection. If we're expecting frequent impacts with a barrier, so with maintenance in mind, concrete can be a good choice as compared to a more flexible system, which if it was struck would need to be attended to fairly quickly, or we couldn't be sure that it would perform if it was struck again.
Thanks, Jamie. So road design note 0308, central barriers and narrow medians is not in your memory stick, but what I'll do is I'll load it up to the resource folder in Moodle right now, but you can always get that from the VicRoads website, 0308.
Here we have another example of a treatment that's been provided in advance of a median barrier, and I quite like this one. We've got this series of short sort of bollards, I suppose, in the median that extend for a distance of 50 or 100 metres in advance of the start of the barrier. So they provide a good visual cue as well as a tactile one. If you were to drive across them in the median, you would feel it. Certainly if you're in a smaller vehicle, and hopefully correct before you reach the start of the terminal or of the barrier. So there's a whole mix of things that have been provided out there, and that really is a key consideration when you're dealing with median barriers.
Do you know a name for that product?
No, I don't. And this snip is from New South Wales. It's something that I encountered up there, and then did a bit of a zoom around Google, finding them. I don't know, and as far as I'm aware, it's I haven't seen it used outside of New South Wales either.
Yeah. So you could probably go to the general product, road safety product companies. There's a number of them that sell a lot of the bollard, like the worksite traffic management bollards and all of those sorts of things, but also sell some temporary and more permanent products as well. Not most of the barrier manufacturers wouldn't be into this sort of stuff, but the barrier suppliers. But so if you want something like that, feel free to give me a call. I'll point you at a few people that will be able to help out. And maybe I'll just have a look behind the scenes and see if I can find out what it's called.
In Victoria, you should be looking to provide the standard treatments provided in that road design note. They do provide some delineation detail with audio-tactile line marking, RRPMs, and some diagonal markings in the median. And the desirable thing to do in accordance with that those guidelines is to install a raised island in advance of the terminal, which is large enough to accommodate some keep left signage and that type of thing. So if you're in Victoria, look to the road design note on how to do these things going forward. So a lot of those issues that we've talked about can come back to the designer. The lines are often really quite blurred, however. The next series of issues sort of relate more to installation. Now, installation issues can come about because an installer has taken it upon themselves to do something different to that shown on the design. That might mean that the design intent is not achieved in terms of shielding hazards at the roadside. They might have some great reasons why they haven't been able to do something as per the design. There might be some underground services or some other thing that's been encountered on site. But if that is the case, it should be put back on the designer to provide some direction or accept a proposed alternative to their original design. They're the ones that have that do understand the design intent. If an installer does take it upon themselves to change things up, they are accepting responsibility if things then go wrong. If someone strikes the barrier and the barrier hasn't been installed in a great way or location, and there's a bad outcome, they may well be legally responsible for that. So again, I'll show you some photos of all of the things listed there. Here's a question, perhaps for a prize. What's the issue here? What's happened?
Oh, all right. So, Doug's quick off the mark there. All right. So we've got some people who are being. So I think we're going to give it to Doug there. First off the back, quick as anything, one word, rock.
Yeah. And look, everyone's right there. Perhaps I didn't phrase the question very well, but certainly the posts are too high, and that's because rock has been encountered. So what should happen if we do encounter rock? What do we do?
Sorry, I'm laughing at Scott's comment. It makes my head hurt looking at it. Yeah, sorry, keep going, Jamie.
Yeah, no, Doug's on it again. Look, we shouldn't. We should be drilling into that rock. We need to ensure that those posts are embedded to the required depth. We should not do what happened here and simply cut them off. So that's what's happened there. You can see the holes there, and the post has just been cut off about here. Not sure which post that was, but you can see those posts needed to be embedded another, 700 mil or something like that. They're not in the ground by very much at all, perhaps half a metre. So we can't be sure that that barrier will perform if it's struck.
So Jamie, just jumping in now, that thing is called just a flexible bollard, and they came in different heights. So
that sounds good. This is the X350 terminal, or the extension terminal, which is now a legacy product. It's not a MASH product, but there are a lot of them out there, and it's a great product. And it did have some great advantages over its competitors, but it also did have more than its fair share of installation issues. So when you see these out on site, there's a few key things you need to be aware of, and one of those is a lack of tension in the cables. So I have two cables that anchor at a point at the start of the terminal here, and then again at the far end of the terminal. These cables clearly haven't been tensioned appropriately. Now, there's not a particular level of tension that they need to have, but they should be reasonably taut to ensure that the terminal will perform properly when it's struck. There's not very much tolerance within this system. There's only about sort of 5 or 6 inches of thread on the cables at either end. So the fact that this is sagging as much as it is a telltale sign that the post spacings are outside tolerance, basically. So it's not a great example of an installation. This is another part of the X350 terminal. It's what's called the slider unit. So this is the interface between the first two rails within this terminal. And it's called the slider unit because this rail here on the right-hand side is intended to slide across the top of the next rail. And this piece here is, I think it's called the angle bar. Its function is to knock the blocks out of the way, the blocks being this black plastic piece here that's attached to the post. So this angle bar really needs to be on this side, on the right-hand side, as we're looking at it, that side of that block. So another common issue with this product was the incorrect installation of that angle bar. This is a Type B guard fence in Victoria. It's a photo that a former colleague of mine from Vic Roads has shared, and he really is very passionate about this. It was actually the site of a fatal crash whereby a four-wheel drive, a vehicle with a high centre of gravity, struck the barrier and went over the top and rolled, and at least one of the occupants was killed. The people charged with fixing this barrier saw fit to try and straighten up the damaged posts and basically stand it up again without installing any new components. So that's not great at all. We can't be sure how that would perform if it was struck, and the fact that it hasn't performed when it was struck in the first case, you would think would lead to a review of the installation and a better outcome than this. Who can spot the issue with this one? It's the ET 2000 Plus terminal, which is now a legacy product.
All right, pop your guesses into the chat or the Q&A. Any issues? Looks like Callum's on to the extruder head misaligned. Post top close to the end. Oh, so the height, maybe the height of the post there sticking up, is that part of it? Post too close to the end is what Naomi's saying. I think that's the right post spot, isn't it?
I think that's fine. Look, they're all sort of standard components, and no, I think that's all good. Yeah, a few people are onto it. It's all about the rail here and how that passes through this extruder head. This is an extruder type terminal, and it's a relatively simple one in terms of its operation compared to the X350. The main issue that we find with this one is that the rail isn't contained within that extruder head. You can see here it's sort of it's not within the extruder head. If that was struck end on, the rail would likely pop out to the near side rather than pass through the extruder head and be flattened out to the side. That might be an installation issue. It's probably more likely that this terminal has been tapped by, a maintenance vehicle or someone mowing or something like that.
Yep, so Callum was on to that one first. There was a few others that got there, but a little bit after.
Here we've got a public domain rub rail at the base of a guard fence, and you're probably more qualified to explain the issue here, Ken, than I, but it's an inappropriate termination of that. There's an exposed sharp edge that is a hazard to a motorcyclist that might be sliding along the ground. There is a standard treatment where we can provide sort of a shroud or sort of a nose at the end of that to terminate it in a better way.
Yep. Now, Jamie, a question's come in about when a barrier guardrail is struck, how you determine how much of the system needs to be replaced and who signs off that?
Yeah, good question. I'd suggest, look, it's any damaged component, any component that is bent or broken in any way, I'd suggest needs to be replaced. It probably gets a bit grey when you sort of reach the ends of the impacted section where posts might be a little bent and not much else. So look, Vic Roads does have an installation and maintenance guideline for flexible safety barriers that provides some guidance around that, and the processes associated with that. We perhaps didn't have that on the USBs, but could provide a copy of that.
Okay, I'll pop that in the resource in Moodle as well. That was...
The ET2000 Plus terminal again. Obviously, it's been concreted into the ground, and if that's struck end on, it's probably not going to budge. I can see how this has come about. Where we have a curb, our barrier height is typically measured to the pavement level rather than the ground level beneath the barrier. So where we've got a curb, our barrier height relative to the ground is effectively lower than it should be by about 100 or 150 mil. And you do often see where a barrier is located behind curb, there's a bit of a recess that's been dug out around the terminal and the barrier to ensure that all of the barrier components are above ground. Here there's no recess, and the concrete infill has been provided, which has meant that the cable that you can see there and the extruder head are partly within that concrete. Lots of blocks. Now the desirable maximum number of blocks is 2. This is a type B guard fence, so it is a product that we're not likely to see as much of going forward, and that's because it's been downgraded in terms of its use. It's now a test level 2 accepted product, so low speed environments only. Its equivalents in other states like the G4, I think, have become legacy products altogether. So it's pretty much proprietary guard fence products going forward. But this type B guard fence, lots of blocks there, I assume because of underground services that have been encountered. It's a bit hard to know how this would perform if it was struck. But I would suggest that there's probably, if it's struck, the posts are going to rotate back, the rail height would increase, and there may be an increased likelihood of a smaller vehicle nosing under that barrier. Here's a dodgy repair job of an ET2000 terminal again. There's a cable sitting over the top of a post here that doesn't appear to be bolted. No bolts down here. So this one might have been struck and certainly not reinstated as it should have been. So keep an eye out in your travels for things like this. At first glance, this installation might look fine to the untrained eye, but if that's struck, it's highly unlikely that it'll perform as intended. Barrier height. This one here you can see is measured in at about 600 mil. The height of barriers has and is increasing to reflect the increasing size of our vehicle fleet. There are a lot more vehicles about with higher centres of gravity, four-wheel drives, SUVs and the like. So in Victoria, at least, the height of guard fence increased by about 40 mil, going back about 7 or 8 years, I suppose. The heights of the proprietary guard fence products now are higher again. We're talking about 800 mil. The newer wire ropes, the mesh wire ropes, are even higher again in a lot of cases. So that is the trend. The other thing that can happen out on the roads is that we reseal them over and over again, and the effective height of barriers next to sealed shoulders where that has occurred can decrease over time. Here we've got a real build-up of gravel and leaves and sticks and so on that has resulted in this barrier being particularly low. And this one measured in at under 600 mil. And it is another fatal crash site. A four-wheel drive failed to negotiate the curve coming down the hill towards us and struck that barrier and went over the top. So the barrier height there, or lack of height, has contributed to that outcome. The ET2000 again, a couple of issues here. I wonder who can spot them.
All right. Chuck in your ideas.
I will point out as people are entering their thoughts that, and Evan may have touched on this, but this is a short version of this particular terminal. For most or perhaps all energy absorbing terminals, there is a test level 2 and a test level 3 variant. The test level 2 variant being okay to use at speeds up to 70 k's per hour, as was the case here. So we're talking, it's essentially the same terminal, but the TL3 version is a rail or so longer. So the TL2 terminals are something like 9 metres long. The TL3 terminals are about 16 metres long. Okay,
we've got a few things have come in there. I think in the Q&A, S Castles, who I'm just not sure your first. I'll look that up, but it's got in there bend in the rail in the ET. So bend in the rail in the terminal itself.
Yeah, look, that's the big one I was looking for. All terminals, all energy absorbing terminals must be installed on a straight alignment. You can see here that there's quite a curve within this rail in particular. Another issue here, I'm not sure if anyone picked it up, was to do with the rail overlap direction. The first rail here is underneath the next rail. So for this type of terminal, the preference is to overlap rails as you go away from the impact head. Now, there's often a bit of confusion around this, and people think that when a terminal is at the departure end of a barrier, you should do it in the opposite direction. So you should continue overlapping the rails along the entire length of the system, starting at the other end and ending up at this end, the departure end. For all energy absorbing terminals, the preference is to overlap away from the impact head as if that impact head was struck by an oncoming vehicle. And in this case, the fact that it's been overlapped this way may mean that second rail may snag before it has the chance to engage and be extruded out to the side of the impact head.
I'm going to give a prize there to Naomi, who said that wrong way in that attachment. And thank you, Steve, who's the username that I was scratching my head to work out. Thanks, Steve. Another one that popped up a couple of times there, Jamie, was the height with the overlays that have been put onto the road, and whether the height is sufficient, and it looks like possibly a bit of a drop there, maybe even.
There is a bit of a drop in here. Yeah, so look, the height in this case should be measured relative to the pavement level here, so the edge of pavement, so not the ground level, so, you know, the base of the post. So it could be the case here that that is lower than it should be. And if overlays were applied over time, that can, you know, further decrease its effective height. And
so that height from ground surface is one, it's an important one as well, for when you've got a barrier on top of a curb and things like that. It's where you've got to measure it from the surface, not from the top of the curb.
Yep. That's right. If you're within something like 1 metre or 1.5 metres of, yeah.
Thanks, Jamie.
This is a wire rope barrier footing that obviously is lifting up. Now that could be because the ground conditions there aren't great, or perhaps what was expected. There are standard details for these footings, and they're a particularly big and heavy lump of concrete. We can't tell looking at that picture how deep the footing is. It could be the case that it doesn't have the required size and mass, and that's why it's lifting up. The standard details are based on sort of average ground conditions, I suppose, and if your ground conditions are sort of out of the ordinary, you might need to do something a little bit different. This is the X350 terminal again, and this is perhaps the biggest issue that we do encounter with this particular system. This is looking down on the top of the barrier near the impact head. It has this component here which we call the locking bar. So this is a vertical bar that has 2 holes in it about this big, and the 2 cables that run the length of the terminal pass through those holes. The idea then is that the bar is rotated to this position, as you can see on the right, which means that cable is it bends through the locking bar. It's deformed as it passes through there. And the idea is that when a vehicle strikes this barrier end on, there's a lot of friction developed between the cable and that locking bar, which brings the vehicle to a controlled stop over the length of the terminal. If the terminal on the left was struck, that cable could pass freely through the locking bar. It wouldn't have very much effect at all on bringing that vehicle to a stop. So look, it's something that's pretty easy to do. There are a couple of bolts you can't see here, but they're sort of down within that underneath here that just need to be tightened up to rotate. Or you can see a bolt sticking out here. You need to tighten up bolts on either side to rotate that bar. And when that's done, it's all hunky-dory. But it often seems to be the case that step is forgotten or neglected, which means that the barrier simply won't operate as it should. Another wire rope terminal footing that has failed. This is not an arrangement that we use anymore. We don't use these sort of pile footings. It's all big rectangular blocks. And this is also a now legacy product that we wouldn't expect to see. So refer to the product suppliers' manuals for the details of their post footings. This is something that should be that surveillance people should be mindful of when these are being installed to ensure that they're installed to the correct dimensions. This one is not to the size that you would be required these days. It's perhaps wider than it needs to be, but it's certainly not as long as the footings are for currently accepted products. They're certainly very big lumps of concrete, something like 800 mil wide by 2.6 meters long, or something like that. Now, there are situations where we can't achieve a block of that size. And in those cases, I encourage you to talk to the suppliers. They can provide you with an alternative footing arrangement. It might be the case that you've got some services at a particular depth and you can't install a block that is as deep as the standard arrangement. The suppliers can provide you with an alternative layout that might not be as deep, but they'll compensate for that by increasing its area in plan view, so that it's got at least the same volume of concrete and offers at least the same level of support and anchorage to the system. We often use intermediate terminals, particularly for wire ropes, and there are standard details for these in the product manuals. This one certainly isn't in accordance with the standard detail. It's a no longer accepted product. So we have two terminals located very close to one another here, and with what's a bit hard to make out, a very slight overlap. Intermediate terminals are provided where we need to provide a break in a barrier because of its length. You might have two wire ropes or particularly long length where we want to provide wire rope. The maximum length of wire rope installations typically being 1 kilometre. We might need to provide a break. We can do that by providing these intermediate terminals. And the key things to think about when you're doing that is the distance between those terminals, and the standard arrangements provide a minimum distance. We've talked before about the distance between barriers being at least as great as the dynamic deflection of the barrier. It's not usually the case at these intermediate terminals because we are so close to the anchor point, but it is at least 1 metre or thereabouts. The other thing to be mindful of is the locations of the points of need or points of redirection. They should be overlapped so that there's no opportunity for an errant vehicle to strike the barrier and enter the roadside at these points. Another picture of a wire rope footing. Now, at wire rope footings, we have this anchor bracket, which should be located centrally within the concrete. This one's obviously located off to the side, and that is commonly done at locations where we have wire rope located behind curb. To install that centrally would require the barrier to kink effectively at its very end to bring the anchor bracket across to this central location. The other thing or potential concern is what's happening under the ground. What can't we see? There is a reinforcement cage to do with this anchor bracket, which requires a certain amount of cover. Now, in this case, it's going to be located very close to the edge of the block, and it may not be installed in an appropriate way. I'm not sure, Ken, if you want me to keep ploughing through or have a short break at any point here. Perhaps one more slide. I wonder if anyone can spot the issue in this case.
Thanks, Jamie. We'll have a look at this one, and then we will have a bit of a stretch and fill up with water or something, and then we'll get back into it. Okay, so there's a few guesses coming in, which are, you have to look pretty closely at this one, don't you?
Yep.
I think we're going to go with Joshua on that one. I think others have been coming up with around the right stuff, but Joshua said it is transitioning between two systems incorrectly, and two products, really, it is, isn't it?
Yeah, we do have two products here, both now legacy products. It's the old Bryphon system in the foreground, which has the weaving cables that you can see here that weave around the posts, connecting to an old flex fence 4-rope system. We certainly shouldn't be combining two different systems in this way. The performance of that barrier simply is a bit of an unknown. It could be the case, I suppose, that someone had a certain type of post in the back of the ute and did a running repair job over a short area. I don't know.
Yeah, a number of different sort of things popped in there. One that came up a couple of times was there's no post cap on the second post in the photo. Is that sort of thing an issue for you, Jamie, or is that just?
Well, a post cap is, good in terms of maintenance and vulnerable road users to avoid someone injuring themselves on a sharp edge. Yeah.
Okay.
I think I might have spotted what's happening here. I can see some remnants of an old footing, terminal rather here. I think we can see the anchor bracket with its teeth sticking up here. This might be an old sort of footing with concrete piles. So I think what may have happened is that this old Bryphon system might have terminated here at one point perhaps, and it's been decided to extend the system, and maybe that was done with a product that was accepted at the time, perhaps the flex fence system, which came after Bryphon. But the old system was kept as is. But regardless, that's a no-no. I don't know if anyone can see that, or perhaps I'm seeing things.
No, Scott. I think Scott put in a similar comment there. All right. Well, let's have a 2-minute break, and so have a stretch and grab a glass of water or whatever you like. We'll be back in 2 to 2.5 minutes, and when we get back, Jamie will just finish off a few more of these, cover off some general stuff, giving us a bit of time to have a chat about those topics that we discussed and any other questions. And we may finish a little bit early, depending on how we go with that discussion, but giving you time to finish off your last little quiz and anything that you still had outstanding to round out the course. So have a stretch. We'll be back with you in 2 minutes. All right, Jamie, let's get back into it. You got some more photos to come? Yes, you do. All right, over to you.
Yeah. So this is another issue that you might encounter with a wire rope anchor bracket. This little guy here is a leveling plate, and the intention is that the top of this fin is horizontal and flush with the top of the concrete. You can see here it's angled back and down quite a bit, and the result of that is that these teeth are almost vertical. They should be angled back to ensure that those cables don't pop out on impact. So there's perhaps an increased likelihood here that those cables will not, that they will pop out if the barrier is struck. It's also just a sign of a poor installation. Water is likely to pond in that in the depression there, which could be a durability issue as well. Here we have an installation very close to the hinge point. In fact, it's pretty much on the hinge point, and it looks like there's some new fill material there. It does look pretty soft. There might be some erosion happening already. So it's questionable whether there is the required lateral support to that system. There's certainly not the dynamic deflection of that barrier between the line of barrier and the hinge point, which is our desirable, but as we know, is rarely achieved. But at a minimum, we need 1 metre, and we need to be mindful of that requirement as well to keep one set of wheels of that impacting vehicle on that verge. Another dodgy repair job. I'm not sure what's happened there, but that's certainly not adequately anchored. And even though it might look okay to an untrained eye, that's not going to capture and redirect an errant vehicle. This, I think, is the same project as the photo that we saw a couple of slides ago. Some widening of a 2-lane, 2-way road occurred, installation of isolated barriers at the edge of shoulder. Perhaps the compaction wasn't there that was required. There was a very heavy rainfall event soon after installation. It saw a lot of undermining of those barriers, resulting in wire ropes, in particular being located right at the hinge point. Now, the biggest issue in regards to barrier height is barriers being too low. Barriers being too high is something that I do find sometimes, and is perhaps less of an issue. It's much more likely the vehicle will go over a barrier than under it. But the main case where I do encounter excessive heights is with wire ropes where the post footings have been mounted up excessively. Now, the concrete footings should be shaped to shed water away from the sleeve, but they shouldn't be mounted up so much that the height of the barrier is outside of tolerance. Now, the correct barrier heights, in this case, are the black lines at the middle of each of these pink bits of tape. So you can see here that this rope, it's perhaps, 80 mil or near enough to it, too high. So there is an increased chance that a vehicle with a low centre of gravity might go underneath this barrier. Tension bays or turnbuckles for wire ropes. Wire ropes, the cables in wire ropes their tension does change over time, and particularly with temperature. They need to be retensioned periodically, or at least checked for their tension. And the desirable situation at turnbuckles is to have scope to tension or detension as you need to. So if we look to the bottom turnbuckle, If we needed to, we could tighten that one up. We could release tension if we needed to. But at the top here, that's pretty much as far as you can go. The thread is just about touching. If it was found that needed to be retensioned or its tension increased, there isn't scope to do that without installing a new turnbuckle. So that's not ideal. Drainage structures do present us with some challenges when we're looking to install barriers past them. And there are often some significant drops associated with these structures, or some head walls or end walls that we don't want people striking. Here you can see we've gone over a couple of box culverts. There's a post in the middle. I'm not sure what that's sitting on, or if they've managed to find a little gap in between. The posts either side don't have much lateral support, so this is not great. There are some arrangements that we can use to omit this central post, straddle the culverts, but where we're doing that, we need to compensate by stiffening up the system on either side. Little culverts can often be hard to spot, as was this one, and the post was driven straight into it. Hard to know if that barrier will perform. Here we have a culvert where we have gone over the top. We've increased the span between posts. If you look closely, you'd notice that we've double nested the rail as well. Trust me on that, I don't expect you to see that. There's a double nested rail. You can see some close post spacings either side of the culvert. And that's been done to compensate for the emission of posts in here. So that is a common treatment that you might see on the network. I wanted to share with you another treatment that I found yesterday actually in my travels in South Australia, and perhaps some of the South Australian attendees can fill me in on this one. It's a very new installation. That's the ETSS terminal. Looks magnificent. I was interested in though in how the structure here was dealt with. You can see there's a bank of culverts, and a treatment has been provided here that has spanned the entire length. We're talking about a span here of about 10 or 12 metres with no posts. And a sort of a steel box section has been used, which has been attached to a couple of posts with concrete footings, so that sort of span of 10 or 12 metres can be achieved. We're talking Ingal products, ETSS terminals, and a little bit of EasyGuard barrier there. I'm not sure if anyone can enlighten me as to whether this is a standard treatment or something that they've seen on the network. But I was intrigued, and it just goes to show that there are some things that can be done for these tricky situations where you simply can't attach posts onto structures, and you can compensate by stiffening up the barrier with treatments such as this.
If anybody has any comments on it, chuck them into the chat, or even feel free to put your hand up and you can talk us through it. But I have certainly never seen anything like that, Jamie. Ground beam would be what I would expect there. But anyway, we'll have a chat to some of our supplier friends as well and see what they can tell us about that. And how did you slip across the border, Jamie? I thought Victorians weren't allowed over there anymore.
I think I made it just in time. No, yesterday there was no trouble at all.
Okay.
I had the relevant travel permit and it was all good. So all of the issues that we've discussed so far are to do with permanent barriers. There are a lot of issues associated with temporary barriers as well, some of them very similar. A lot of the same design principles apply to any type of barrier, permanent or temporary. But there are some specific issues as well that are associated with some of the temporary barrier products that we commonly use. Particularly in built-up environments, you do commonly see temporary barriers used for purposes other than keeping errant vehicles out of work sites or capturing and redirecting errant vehicles. In this case, we have an innovative use of some temporary barriers as sort of part of a scaffold. I don't think I'd feel safe working on top of that. It's perhaps more of a delineation or device than anything else. That's not an appropriate use of those systems from a road safety point of view. Installing add-ons such as the fence there is not something that should be encouraged. We also have a combination of products here. I'm not sure if they're connected in any way, but again, that's a bit of a makeshift use of these type of products. As with permanent barriers, any temporary barrier needs to be appropriately terminated. Here we have a barrier with no terminal on it. The exposed end there is significant hazard to an errant motorist who would come to an abrupt stop if they were to strike that end on. Lots of little bits and pieces of barrier there, again, primarily as a delineation device or a device to keep vehicles or discourage vehicles from using certain parts of the roadway. Another temporary arrangement. Now, this is something that has been accepted in the past, but is no longer accepted, and that is flaring barriers to a point outside the clear zone, such that the start of the barrier is located outside the clear zone. This is a concrete system, a rigid system, and the end of that system is a significant hazard that should be terminated. Flaring it outside the clear zone is certainly not something that is adequate. You can see in the background there's a wire rope as well, nearer to the other carriageway. A vehicle on the carriageway that we're looking along that left the road into the median and struck that wire rope may well be directed towards this exposed end of the barrier. So that's not great at all. A plastic temporary barrier overlapping a concrete barrier with no connection. There is a pocketing risk there if a vehicle was to strike this barrier in advance of the concrete section. A few things going on there, a bit of concrete barrier as part of the scaffold. We also have a bollard in advance of the column here, which there are some accepted bollard products available these days. They're not a barrier, but they do provide some benefit in containing or at least slowing errant vehicles. We are in a relatively low speed environment, as you can see here. So that bollard appears to have been installed to provide some level of protection to those columns. Not much, though, I'd suggest. They do have their place, however, these type of bollards. I see them used on occasion in some particularly constrained locations where you simply can't do much else. Here we have an exposed end of a concrete barrier. There's a pole just off to the left of screen, very little space to play with. So a couple of these energy absorbing bollards have been installed to try and help a vehicle wash off a bit of speed before it strikes the end of that barrier. So they're providing some benefit. Maybe the arrangement could have been improved a bit to help even more. For certain approach angles, this barrier is still exposed. Perhaps if this bollard was over here a bit more, that might have been better. These type of things, I think, serve the greatest purpose in locations such as curbside dining, deterring vehicles from entering spaces that are used by pedestrians. Now, these bollards have a capsule under the ground, sort of a sacrificial sort of foam capsule that sort of provides some resistance to the impacting vehicle. So they are accepted for use in some low-speed environments, and particularly where we've got pedestrians. Temporary barrier separating a walkway and a traffic lane. Now, these barriers, as with any barrier, deflect, and in this case, this barrier will deflect quite a bit if it's struck. I don't know how safe I'd feel walking along there. If that barrier was struck, it could be expected to deflect well into that walkway, as has happened here. Now it looks a bit wet here. I suspect the water-filled barrier has been damaged and there's been a bit of a spill. Often you find these things aren't filled with water, they're just there for looks, but in this case it appears that it was filled with water, but even still it's deflected by a significant amount. Another little makeshift terminal that we found out and about on the network. It's a version of sorts of an ET terminal. Very short. It's an extruder type terminal, but I don't think that's going to do much extruding. It's got timber add-ons and there's fences in behind and all sorts of things going on there. Scaffold located behind a temporary barrier, no length of need to speak of there. Our concrete barrier sort of doesn't extend past that scaffold at all. A vehicle that passes through here and even strikes the terminal can be expected to plough into that scaffold. As with permanent systems, we do seek to provide run-out areas, and in this case, we have provided an appropriate run-out area. I'll skip through. I've got lots of photos. Just being mindful of time. Here we have a temporary barrier, direction of travel from left to right, an overlap with the concrete barrier to a plastic barrier. So that sort of all looks okay. But from another angle, we see that plastic barrier is sitting at the very top of an excavation with a significant drop. If it's struck, it's going to deflect and it's likely that the vehicle will end up going over the drop. So there's lots of issues that we do encounter with barriers, and I've probably just scratched the surface here. There are a few things that have been done and are being done to address a lot of the issues that we encounter with barriers. A process that came into Victoria in 2012 was around suppliers warranting that their products have been installed correctly, and issuing a certificate of compliance for the systems that they supplied. Some standard sections went into VicRoad's contract documents around guard fence barriers and wire ropes, requiring the supplier of the product or their representative to inspect each installation and warrant that it had been done correctly, or provide remedial measures to ensure that it was appropriately installed. So that process led to over time, a significant reduction in the number of installation issues that occurred out on site. A lot of the issues associated with installation were from the new kids on the block. Some of the bigger, more competent suppliers had very few, if any, issues, but It was the people that decided that they would turn their hand to barrier installation and didn't have much background with the industry that where most of the issues were encountered. There is a system in the pipeline, a national safety barrier accreditation system and process whereby installers of barriers and even designers of barriers will need to be accredited. There's a UK company called Lantra that is working with Austroads and ASBAP to implement this process. And that will require anyone involved with installing a barrier to be accredited. There are different levels of accreditation, right through to from sort of base level labourer, right up to lead installers and designers. And those installing barriers will require specific accreditation for each of the products that they are dealing with. Oops. And there's a snip of the Victorian contract section around certificate of compliance requirements for wire rope safety barriers. So I encourage you to look to all of the available guidance to understand the ins and outs of the different systems that you're designing with and that you're having installed on your network. You might be maintaining barriers, surveilling their installation. You can refer to the product suppliers' manuals. They often even have videos, which are quite handy and useful to show you the ins and outs of the products and how they should be installed. In Victoria in particular, there's lots of specific guidance, and that is being consolidated and streamlined at the moment. The other document that we mentioned is the Flexible Safety Barrier Installation and Maintenance Guidelines, which we'll provide a copy of. It's a VicRoads document, not available at the website, but it's a handy reference tool. And it really does bring together a lot of the important design considerations and installation issues that are encountered out on the site that you can find in all of the other relevant documents, but it brings together a lot of the key stuff into one location. So that's it from me. I'm happy to take any questions on any of those things that I've covered now, or anything that else that might come to mind. And we also have those couple of questions that have already come in, Ken.
Yeah, thanks, Jamie. And we did have a couple of good comments in there from Steve about the different temporary products as they were ticking along on some ideas. So thanks for that. And yeah, I think Jamie's done a good job of showing we get issues all the way through that process, the design, the installation, the maintenance. It's there's lots of challenges to look out for. And hopefully you've got some understanding of the fundamentals, which is great. And then you always have lots of documentation available to you as you are out there, maybe looking at an existing barrier and you're not sure, how it exactly should be set up, or end terminals, usually the ones that are a bit trickier. And you can go back to their documentation. They often have little installation videos that you can look at. So some information available. I will just show you on Moodle where you can find some of the resources. I think you're all fairly good at using that. You seem to have been able to upload your assignments and everything like that. But in the barriers one, you have this resources and reference documents and resources. So just in there, you'll see that I've now put in the maintenance and installation guide. That's the Victorian document, but others might find it interesting. The barriers in narrow central medians document, which was mentioned, and then you've got terminology document, the Austroads guide, part 6, and this is the Victorian accepted products. But remember to always use the most current one when you're doing that. So that's that. Let's Now, please, yeah, as I'm going along, continue to add in questions or comments, but I might just show you a few pictures here. So, Jamie, hopefully you can see the high-profile barrier curve there.
Yep.
Yeah, so that was a question or a topic that's come in, a bit of interest in different ways to think about this type of product. Now, there's a number of different profiles on this, and just putting up a few different pictures, but it's essentially a very high curb, concrete curb. So there's that one there. There's a different profile one. That's a Victorian example there going in. There's one being used to, separate a bike facility. And so they have some redirective quality. There's another few of them. So people can be aware that it is a product that's available, but I'll get Jamie to talk a little bit about them, but I will point you to anybody who's thinking about using them. The use of high profile barrier curb is again, another Vic Roads Road design note, which has some information about a couple of the profiles or the type, Midwest and the drive. So they're there, and then within here are the standard drawings of those types. So you can see those there. So any comments on, Jamie, both where you would and would not use these and why you might use them, and any other sort of considerations from your perspective?
Yeah. Look, high profile curbs, they're not barriers, but they can perform the function of a barrier to a degree. They shouldn't be used in high speed environments, but they might be an appropriate treatment in a low speed environment, perhaps where you've got cyclists that need to be separated, or you might have trees in a nature strip or a median that you want to reduce the risk of, or you might have pedestrians behind the curb, perhaps on a structure or something. As Ken mentioned, there's a number of different profiles, and the Vic Roads Road Design Note mentions a couple of them. I know that the L. Schultz barrier profile is used in New South Wales. I think it's a lower profile again. Some of the products have been crash tested, not to MASH requirements, but to some older crash testing protocols like NCHRP TL2 perhaps. So in low speed environments where you've got a desire to prevent vehicles or reduce the likelihood of vehicles entering a pedestrian area or striking trees or other hazards in the roadside, this might be an option. Yeah,
and certainly those general considerations that any of you that do road safety audits or the like would always consider. Yeah, pedestrians trying to cross at these points, obviously something bigger to try to get over, those sorts of challenges, and then any ends of them and starts of them and how that all plays out. So take your usual common sense look at it from a road perspective, but there's a bit of guidance in there available to you. So that is high profile barrier curb. I've got a question here. Can you combine them with other barriers?
Not with a road safety barrier. We couldn't be locating a guard fence or something like that behind the interaction between the two. We just wouldn't, we wouldn't know how that would work. But that said, these being appropriate for low speed environments, they're sort of not the locations where we might think a barrier would be required anyway, but we, in terms of shielding, protecting the occupants of the vehicle, it's more about probably the other vulnerable road users as a general rule. So you wouldn't need a road safety barrier at a location where you're proposing these typically.
Okay.
You might.
Oh, continue, Jamie.
I was just going to say, something you might look to do is provide say a pedestrian fence along with one of those. So the pedestrian fence stopping people from going onto the roadway, and the high profile barrier curb preventing those vehicles or from entering the pedestrian area.
Okay. Callum was just pointing out that in South Australia, they used to use them on some bridges with a thri-beam on top of them, which I imagine would make sort of a high, fairly strong barrier system, but I'm not sure that would ever have been tested in any way, shape or form.
Yeah, I haven't seen that.
Okay. Good. All right. Well, thanks for that, Jamie. Let's just have a little bit of a chat about pedestrian fencing now. So, again, so there's actually a really recent road design note. So some of you might have missed it, and it's the Feb 2020 road design note 0614 for the Victorians. And again, you want to see what your jurisdiction has before you start moving to other jurisdictions as a next option. But so if your jurisdiction has some specific guidelines and the like, use that. So that's got some information in there about different pedestrian types of fences and the like, and the design of them, some things to look out for. And there is one thing that I tend to use a bit, road safety auditing, or I've used a little bit, is at the back. Right at the back of this, I'm pretty sure it is at the back of this. Yes, here it is. There's a sort of checklist that helps guide you through the thinking of any new fencing and whether it's appropriate, what type, is it the right type, does it present any other hazards? And it's quite comprehensive, but it is worth working through if you're going to go, if you're doing any work in that pedestrian fencing space. So there's that, and I think there's a standard drawing of, here's one of the sort of pedestrian fence types that's been around a while, that standard drawing for the welded mesh fence. Now, there are bicycle specific fences as well, so just be aware that there are those, and I think there's an Australian standard on bike fences. Amy?
I'm not sure. Probably there's an Australian standard on most things.
That's right. Any comments on pedestrian fencing in general, Jamie?
Yeah, so look, Victoria has this road design note. Each jurisdiction's got their own standard details for pedestrian fences. They all differ a little bit, but I think another question coming about pedestrian fencing and also fences adjacent to cycleways. So where we do have cycleways, we need to be mindful that whatever fence we provide doesn't create a snagging hazard for cyclists and something they might snag their pedals on. And there's a number of ways that's often achieved. You can see that one there with a rail on it. The heights of these fences can depend on the road users adjacent to them. The standard height's lower if we've just got pedestrians as compared to if cyclists are present as well.
Yeah, thank you. And over structures, Jamie?
So any fence on a structure needs to meet the bridge code, AS 5100. So there's a little bit of guidance in there around those types of fences. And on the structures, typically we have a pathway at the side, which might cater to pedestrians and perhaps cyclists as well. And our options are to just have a barrier on the outside of the structure that can contain vehicles, or perhaps we'll have have a barrier at the outside of the structure and another one between the pathway and the structure. And if we have that barrier between the path and the roadway, it might be one that's intended to contain errant vehicles, or it might be one that's just intended to keep the pedestrians off the road, in which case we then do need a containment barrier at the edge of the structure.
So in this example, so there's some sort of bridge containment structure somebody came up with over there, but if you, maybe, I don't know, were trying to create this into a shared path, or you were worried about pedestrians entering the roadway, you would be able to add your sort of pedestrian fencing along here, but you're saying you need to make sure it is in accordance with the bridge code. Is that right?
That's right. And I think it's, that's not to say that you can't use a Vic Road standard treatment, but the road design note in fact does refer to the bridge code requirements. And as I understand it, the requirements for these type of fences as per the bridge code are fairly general. They talk about the height and the nature of the fence and its surface and that type of thing. This might be a location where a high profile barrier curb mightn't be a bad idea. Between the road and the path, perhaps we could have a high profile barrier curb and then a pedestrian fence at the top.
Yeah, okay. Yeah, so that may cover off a little bit of the question that's just come in there, with the fact that a pedestrian fence certainly will not contain a vehicle, and vehicles will smash through it, no worries whatsoever. And so it's really providing no protection to the pedestrians in that sense. Pedestrians may feel more protected, but certainly it's not the case. So the question really is, what can you do in those situations? You've already just mentioned one there where you could possibly consider a high profile barrier curb with the pedestrian fencing on top of that, which would do that. What else do you think there?
The alternative would be to locate your vehicle containment barrier, in this case, sort of where the curb's located, and then have a lesser fence, for want of a better term, at the outside of the structure, one that would prevent a pedestrian from going over the edge, and that would clearly provide better protection for the users of the path.
Yep, absolutely. Very good. All right. Well, thank you. We covered off those, and yeah, they're very much things that could go into a lot more detail. But bridge barriers are a whole entity in their own right, and we really haven't covered that. But it is important to know that they are different, and they need to be considered very differently. So some good information there. So we just. So all you've got to do at the end of this one is scroll down to our final module, which we are. There you go. You'll see that we'll be uploading the recording like we've done here shortly, so you can catch up on that. And click on your Module 4 quiz, and you'll be very happy to know it is simply one question for this one, and that's just how many Wallies did you see? Now, Jamie, a question's come in the chat. You read that while I'm talking, because it looks like it's a long one. We've got just a little bit more time left. So finish that off. Then finish off anything else that you've missed, any quizzes that you didn't manage to do, or your Know Your Barrier product. Make sure you upload that. Once you've done all those, as long as you've got over the pass mark, the 80%, you'll be emailed a copy of your certificate, and you'll be sent a hard copy of your certificate in the mail with any prizes that you've collected along the way. And of course, if you're having any trouble or you've got any follow-up questions, get in contact with myself or Jamie, and we can walk you through that. So Jamie, was that last one you manage to see the chat there?
Still just trying to get my head around that. I can't say I'm familiar with those type of devices, so I might have to take that on notice and get back to you. So the question is about longitudinal channelizing devices in place of temporary water fill barriers.
Okay. Right, so that's one there from Steve. Yes, it is Steve, isn't it? Yeah, Steve. So we might have a look and come back to you on that one, Steve. Okay. Well, I think we've pretty much winding this one up. So I'm going to stop sharing. I just want to thank you all for being part of this, and you've been a very active group in terms of the comments and the questions and the answering the questions and getting things done. Really appreciate that. We hope you got something out of this. It's always very much intended at making sure everybody's got a solid understanding of the fundamentals of road safety barriers, and then, as I say, we offer a 2-day applications course which goes into quite a bit more technical detail and gets you calculating some of those things. Unfortunately, the applications one we don't offer as an online version at the moment. That's really because we like to get out there with you at a site and talk about the constraints and the services and how you might, which barrier you choose. So it's a very hands-on, out there one. We do run it in New South Wales and Victoria at the moment, but we may look to go into some other jurisdictions on that. But as these sort of things go, we have come up with some different ways to present this stuff. So we may have to look at that depending on how our COVID situation continues to go. So we'll keep you all posted. We've got your contact details now, so you'll be able to keep abreast of what's going on in terms of that offering. I think you'll love that next component of this training. But I hope you enjoyed this one, yeah, finish off your last things and get in contact if you've got any questions. Thank you, Jamie. Always great to tap into your wealth of knowledge. Very much appreciate it. And thank you to all of our participants. See you at the next training.
Thanks, everyone.